All right, we'll cover tutorial question 1 to 7. And in the later chapter, you will see we'll look at stagnation point, what happened to stagnation point. But at this moment, we just have some introduction on how to plot the graph and how the velocity field you can be scratch it out. All right, now we move on to the next one. So how we analyze the fluid mechanics problems. So there are two. So we're going to look at two approach or two method that we use to analyze fluid mechanics problem. We have two. So given by these two gentlemen name, one is Eulerian, one is Langarian. So fill these two names in your tutorial sheet. So there are two approach to analyze fluid mechanics. One is Eulerian, who is focused in a function of space and time. And we just now, this morning, we mentioned the space referring to the coordinate, the spatial coordinate, x, y, and z in the Cartesian plane. And then time is time, right? T. Langarian method is focused on individual fluid particles. Later, we'll look at it in the next slide. Langarian method focus on individual fluid particles and is look at the function of time only. So there are two different, big difference between these two methods. Eulerian focus on space and time. It means every time you see Eulerian, you will see you have x, y, and z and t. However, Langarian method, you only have in a function of time and is follow individual particles. Okay, we look at the diagram. So on your tutorial sheet there, you see a diagram. So we look at this diagram, and then from this diagram, then we try to explain what is Eulerian and Langarian. Okay, now if you look at your tutorial question number 8, there's a diagram there, which on the slide here, you will see there's a sensor, right? On the left, you see there's a sensor here. There's a probe there, which is stationary. And on the right-hand side, we don't have any probe. So let's say we have a chimney, we have a channel to, there's a smoke coming out. There's a smoke coming out from this opening. There's a smoke coming up from this opening. So this is a 2D cross-section. You imagine this is a cylinder. And then we cut the cylinder, we cut the pipe, we will see the cross-section, this one. And the smoke was coming up from bottom to above. Bottom to above. So what is Eulerian method, which is the first method? So Eulerian method is we make measurement based on the stationary probe. Means you stand there without moving, and then you just every smoke that you just measure the velocity of the smoke at this stationary station. So when we write the equation, we have x, y, z, and t. Right. So we just stand there. The Eulerian method, you have a probe there, you have a sensor there, and then you just put the sensor there to measure the smoke, the velocity of the smoke particle, for example. However, for another method, Langarian method is on the right-hand side. You see there's a highlighted cube there. So this is a one element. So Eulerian method is follow this particle moving along the time. Right? You'll follow maybe from bottom until this particle stop. So these are the two main method that we use to analyze fluid mechanics problem. Okay, the detailed explanation you can read from a slide later. So these are the two main concepts. Right? As long as you understand what is Eulerian method, what is a Langarian method. Eulerian method, again, you just at a stationary position, then you measure the flow like you normal do measurement. Right? Yeah. And then Langarian method, you will follow, you will like do tagging. You have one sensor mounted on one of the particle, and then you just follow what happened to the particle, individual particles. Langarian focus on individual particles. However, Eulerian focus on the space and time. Right? You do not move, so you just stand there and then measure what happened to the environment. Okay. Right. Now, on these slides, you will see there's a buoyant ball here. And then this buoyant ball was measuring the amplitude of the wave. So, for example, if this buoyant ball, was fixed to a location, and then let it float up and down, then this one become Eulerian method. Okay. Now, if we cut away the string attached to the buoyant, and then we let this buoyant ball to follow the wave along the sea, right? Along the wave, to let it float, and then we see how it will arrive after a certain time. Then this one become Langarian. Okay. Yeah. Again, the detailed explanation you can read from the slide later on. Yeah. Yeah. Basically, I just summarize what is these two methods in a layman term lah. Okay. Now, application of these two methods, either it is Eulerian or Langarian. On the slide here, you will see we have weather forecasting on the wind direction. All right. Wind direction, and then the movement of the wave, sea wave, from the satellite images. And then also application for the turtle movement. We mounted on a turtle. There's a sensor there. Yeah. So if you mounted a sensor on an individual particle, in this case is a turtle, and then you track it on a map, this method is called Langarian method. This is the second method. Okay, Langarian method. All right. So what about Eulerian means you put a sensor there, and then you for example on this map you put a sensor on the beach here, and then you just measure total of turtle that come on the beach. You sense on turtle, you sense on the movement of the turtle on the beach. Then that one become Eulerian. All right. Any question? Bila? Muhammad Bila? Bila, are you there? Bila? Bila, are you there? Why I cannot hear anything from you guys? Bila, are you there? Bila, can you turn on your mic? Sue, are you there? Su Jinghao?
Yes, sir.
Okay. Brian, are you there? Why are you not there? Bila, are you there? Brian, can you turn on your mic? Bila, are you there? Bila? Hello, Bila. Vina, are you there?
Hello, sir.
Yeah, are you there? Okay, so you have any question on the Eulerian and Langarian method?
No, sir.
Okay, good. All right, we move on. So if you have any question, just stop me.
Okay, sir.
All right. We continue with slide. So let me know if not able to see slide. Sometimes I will forget to turn on the share screen. All right. We have cleared these two methods. Sometimes in your assignment, in your lab session, you need to explain these two methods. Now, number 9, question number 9. Three-dimensional flow is very important to have an understanding on the effect, physical effect. So, for example, the vortices after the wing, airplane wing, as you can see on the slide here, is a three-dimensional flow. And also on the simulation, on the aerodynamic studies, on the flow, on the this one is a rocket model. So we want to see what happened to the reaction on the air when they contact with the surfaces. Right, this is a three-dimensional characteristics, very important in terms of physical effects. So make sure you fill the blanks in your tutorial question. And every time we mention about three-dimensional, again recall there's a general equation we covered this morning. V equal to Ui plus Vj plus Wk. Make sure you're very familiar with this kind of term. Again, the first term is x direction, x component. Second one is y component. And third one is z component. Okay. Now, what about two-dimensional flow? Two-dimensional flow means we only have two of these components. For example, if we don't have the z component, like the question in question 7, we don't have the, all right, then our equation will become only have I vector and j vector. And in your test one or in your final exam, you will not be so direct. Sometimes you don't have x-axis, it will turn out to be in a y-axis or z-axis. As long as when there's a two-dimensional flow, you only see two terms there. It's either xy or yz or y z something, or zx condition. All right. And of course, one-dimensional flow, you only have one term in the vector direction. In this case, I give you an example. This is, we only have one vector form in the x component, ui hat. Then this equation, this vector form is one-dimensional flow. So you have to have a basic understanding on the keyword. When the question you see three-dimensional flow, it means something. When you see two-dimensional flow, it means something. And then one-dimensional flow, it means something. So for example, the question asks you to analyze the flow pattern in one-dimensional flow on x-axis. So you write the general equation in this form. So if the question mentioned develop equation, a two-dimensional flow equation in the y and z axis, then you will have the z, the j component and k component equation. Right now, so three-dimensional flow, two-dimensional flow, and one-dimensional flow. Make sure you understand the difference between these three. And every time you see this one, the keyword in the question. So you need to find out the keyword inside the question, or sometimes in your assignment, asked to analyze a three-dimensional flow. Then you should have the three component, for example. Okay, we have clear question number 9. And we now look at question 10, tutorial question 10. Now we're going to look at what is streamline, what is stick line, and what is path line in the following lecture. Okay, and this streamline, stick line, and path line is as a tool for us to visualize. Or in application, you will see this streamline, stick line, or path line in the simulation software. The simulation is a visualization tools. Right, now we start the definition of these three. So what is streamline? All right. Now what is the difference of streamlines? So streamlines, the application normally used in analytical work, just a note in your tutorial sheet there. So streamlines was used for analytical work, means you need to analyze, there's an equation for you to use, and then you need to calculate it. Then normally you will see streamline, this keyword in the question. And if you see the word stick line, path line, this one, usually it will appear in the lab component or in your lab report or in the experimental work. This one will usually in the lab component on your lab report, or sometimes you're given a data to analyze, a data that collected from the experiment. Then you're able to do the stick line and path line. These are the differences or characteristic of this three, between these three. All right, now the definition of streamline is a line that's everywhere tangent to the velocity vector. So on the diagram here, so you can sketch this diagram on the space given in your tutorial. Sketch this graph. Start with the axis, x and y, and every time you only see x and y, this is a two-dimensional flow scenario. So x and y, and you have a line, a curved line here. So this curved line, you imagine line consists of a loss of repeated dot here, small little dot. And we choose one dot here, right? Choose one dot here. For example, I use activate my pointer. So let's okay, there's a dot here, dot here, dot here, dot here. All right. So we focus on one dot along this blue line, and if there's a dot here, we draw the velocity vector from this dot, and this dot was tangent to the velocity vector. Then we connect all the dots together, we get streamline. So the blue line that you see on the screen here, the blue arrow and a curve, or you can say it's a curve, this is a streamline. So all the point on the streamline here is actually consists of a vector component which is tangent to each other. Right. So for example, this dot here, I just enlarge it. This dot is tangent, means a tangent to the curve, tangent to this dot. And then when you focus on this dot, there's another tangent vector here. If you focus on this point, there's another tangent vector here. If you focus on this point, there's another tangent vector here. And there's a dot here, then we'll see another tangent vector here. Okay, so streamline actually is a combination of the velocity vector. Okay, let me erase this one. So, another new term for today, steady flow. What I mean by steady flow? If you have a steady flow, means every dot on the curve, let me use my pointer again. Oops. Let's say we focus on this dot, 0.1, 0.2. So we have a steady flow from 0.1 to 0.2, means there's no change of velocity. V1 and V2 is equal, meaning no acceleration. No acceleration. Okay, no acceleration from point A to point 0.1 to 0.2. Then we have steady flow. And streamline are fixed line in space, so they are fixed. They are fixed. So if you have unsteady flow, then you will see this streamline will change shape. All right, your streamline will be like this, something like this. Okay, these are unsteady flow. Steady flow will be like this, will be like this. Uniform flow or steady flow. This is a steady flow. Okay. Right. So in your tutorial, you have a 3 question there. What happened in the steady flow streamline? So if you have a steady flow in a streamlines, then they are fixed. They are fixed. Then if you have a unsteady, then the streamline will change shape. And then we look at how streamline can be obtained from analysis. For example, if you want to visualize, steady flow, you just draw like this. This is a steady flow, streamline. You want to draw unsteady flow, means this is an unsteady flow, streamline. This is a steady flow streamline. This is unsteady flow streamline. Okay. Now sometimes in your exam, you need to stretch out the streamline from the equation. Okay. Now how to generate streamline? So you need some space for this one. So the space given in your tutorial is a bit narrow there. So you can use this any extra paper if you need. So there's a procedure. Every time in a question asks you to generate a streamline, there's a procedure there. So the keyword here is you will use the differentiation and integration, right? So recall what is differentiation, what is integration from the mathematics class. All right. Now in the diagram that you just draw on your tutorial sheet there, so we know that streamline is actually the velocity vector is tangent to the point. So every time you know that tangent, you can draw the gradient of the vector dy and dx, dy and dx of the vector. And then you know that all the vector along the x-axis we can denote as a u, small u, and the vector along the y-axis, we can use the small v vector. Okay. We are going to look at the procedure to generate the streamline. So every time we are given an equation. So in this example, we have a 2D velocity vector here. This velocity vector, the red color arrow is a 2D velocity vector. You break it into x-axis and y-axis, right? And then we have the slope, right? So slope of the streamline is actually, by definition of the streamline just now, is a tangent of the velocity vector. So we have slope. How we find the slope? We take dy divided by dx, this one divided by this one. And then on the right hand side is a definition of our streamline. So in this case, we break our vector u divided by u vector. Okay, so this is the equation. Every time we want to build the streamline, we need to identify dy dx equal to v divided by u. In this case, we are in the axis of y and x. Of course, in the exam, it won't be so direct, because when you come to online exam, you test your intelligence analyzing the question. So if your graph, if the question asks you to analyze, for example, I change the axis y and z here, so this component is no longer u. If I change this one to z, this one will become w. Z-axis will always use w. So your equation here, you can no longer use u, you must replace with w. So this is how we manipulate the question. Right, the concept still same, but I want to see your intelligence in the answering the question. Now, in this slide, show you the first step to generate the streamline. We get the slope and the tangent equation. Slope dy dx, this is fixed already, mathematics. Only change is the vector form. Tangent, it depends on the axis, in this case y and x, so we have v divided by u. Okay, make some notes in the slide, in your notes there, special notes that you need to focus on the axis. These two depend on axis. So how do we arrive from here? So for example, on the notes, on the side notes, v, velocity, we know that it's a change of y towards time, right? V equal to dy dt. V equal to dy dt is a change of distance traveled in a y direction towards time, dy dt. U, again, u is a x component. So distance traveled by the particle in the x component, dx, divided by dt, we get the velocity. In this case, velocity vector in the x component, we use small u. Then you rearrange the equation, as I show you on the slide now. You simplify this equation, the dt will be gone. At the end, you'll get dy dx. At the end, you still arrive in the same equation. All right. Then we move on to the next slide. Move on to the next slide. All right. Okay, this slide, let me do some improvement on the slide because of the size, the text size. Okay, now on the slide itself, you see there's some error again, a typo error. On your tutorial question also, please help me to change the equation. On the question 12, you see there's a velocity vector given. So you see v equal to v0 divided by L minus x vector j So that is wrong. Correct the j hat to I, as I show you on the screen right now. There's a typo error there. And you're given that V0 and L is a constant. Is this equation actually, we have seen this one in question 7, is the same equation. Just that question 7, the objective is to draw out the velocity field. However, in question 12, it asks you to do another things. It asks you to determine the streamline. Okay, determine the streamline. So every time we ask you to determine streamline, again follow the procedure. We need to establish the dy dx equal to dv equal to v divided by u. So the first thing, oh, I forget to. Okay, never mind. Just follow the slide. So we know that u equal to negative v0l times x. This one we covered already just now from the equation. I explained already how to get this one from the general equation. All right. If you don't understand, refer to question 7 later on. V also the same. V also the same. Extract from the equation given. This is a V component from the equation. You just break this equation into U, V, and W, and then rewrite it back. So streamlines is given in a solution. So you write out the dy dx equal to V divided by U. So just now we already have the U and V in xy term. Substitute these two equations into this equation. So dy dx equal to V divided by U. Substitute it into this equation. Substitute. And at the end, you can take away the same factor. In this case, the V0 divided by L terms, you can take away. At the end, you arrive at y divided by negative x. Again, be careful on the negative sign in this module. It will mean something if you put a negative there, right? If there's a negative, means that it was opposite from the assumed direction. Throughout this module, all the direction to along, if you follow x-axis, it will be positive. If you get a negative, means you go opposite. Same with other axes also. Okay. Now, at this stage, we arrive at the new equation. We have dy divided by dx equal to y divided by negative x. This is the differentiation equation. Recall back what is integration, how you integrate the differentiation. Means from the slide here, on the screen here, you see dy dx. Move your dx from the left to the right. Move your x, move your y to the left. Means you put the dy one side, dx one side, and then put in the related term together. So in this case, we have this form, dy divided by y. Why there's a divide by y? Because y divide by x, or you can pull x here. You rearrange this equation, you get this form. So we have integration on both sides. This is a mathematics equation. So if you don't know how to integrate, go and read your mathematics handbook. Okay. So we know that if you integrate something 1 divided by something, this one become a ln, right? This one become a ln. So this term on the left, y component become ln y. And then negative, you pull up, you get negative, and then this one become ln x plus a constant. Means every time you integrate without the boundary condition, you get a constant value, or c, plus c. So you don't understand this equation, please refer back to your calculus chapter in mathematics that involve differentiation and integration, the chapter. If you don't understand this relationship, then you pull the negative from the negative ln x from the right hand side to the left hand side. You have ln y plus x, ln y plus ln x, ln a plus ln b, you get ab. And this one also in your calculus or in your advanced math. So you have xy equal to constant. Okay, now transformation from here to here, if you don't understand or you lost, mean that you need to polish up your advanced mathematics in integration. So we have xy equal to constant. Constant means is either 0, is have a value, 0, 1, 2 until any number given. So streamlines actually is the integration of points. So we look back at the slide here. This slide. So this is a streamline, consists of all the velocity vector. So you want to get a curve, a line, means you integrate. You do the integrate from the differentiation equation. Okay, now we have one equation here, xy equal to constant. Now, for example, you forget what is the shape of this equation. In question 7, or in the earlier this morning, I introduced you one online platform, right? Okay, you can use online graph plotting. Again, I'm going to show screen. Again, I go to the, okay, I'll show you one more time. You go to Google, you go curve plotter. You search curve plotter, you go to the first link here. You can use the first one or second one, same developer, same software developer. You click the first one, you arrive at the page that shows you on the left hand side where you can key in the data. On the right hand side, you will see the graph paper. So on the calculation just now, we have this equation, xy equal to constant. You want to see the shape of the graph. So you just go to the empty space here on the left hand side. How to input data, on the bottom there, you see there's a keypad. You just expand it. Key in the equation, xy equal to a constant value. We start with 0. We start with 0. So xy equal to 0, you get a straight line. Let's see what happened. Xy equal to 1. Xy equal to 1, you get the blue color, because on the screen here you have red color, blue color line. So blue color line represent the second equation on the screen here. I roll my mouse here. And then you continue. Xy, you can type with your keypad also, with your keyboard also. To, let's say continue until 5. You can just, as a simple finger exercise. Okay, let's stop at xy -4. What happened to the quadrant on the left and on the bottom right? Let's try the negative value. What happened if we input negative value? Xy equal to -1. So you will see it will appear on the diagonal section of the graph. So xy equal to -1, it appeared here. That I'll show you using my mouse pointer here. And let's try another one, xy equal to maybe -2. You will see this shape and so on. Again, for this module, you're allowed to use online platform, any calculator plotter to help you to plot the shape of the graph. Right? My objective is not It's not to test your capability or how good you are to plot graph, but we want to see your intelligence in using technology, and also do you understand the steps, the principle in solving problems. In this case, in this example, in tutorial question 12, you need to plot the streamline. Okay. Now we have this shape. We'll come back to this shape later on. All right. Now, in this case, in this question, we are only interested in the x more than 1. X more than 1, I mean x positive value. All right. So we only look at the right hand quadrant or left hand area that are shown on the screen here. We're only interested in this area. And then from this graph, you export it into your answering sheet, and then you scratch it out. You just copy the shape that you see on the screen, right? You just copy the shape accordingly. So in this case, I'll show you example. Just now I show you example, the constant value 0 to 5, and then also negative. You can study the the shape at your free time. So from here, you will have C equal to 0, and then 1, -1, and so on. You can see the value. So these are the streamline when you have a certain value or constant. Okay, any question on this one? Any question? Let me check. Joshua? Joshua, are you there? Joshua? Joshua Guna? Joshua? Chong, you there? Chong Hong Ki?
Yes, sir.
Yeah, you're there. Okay. Any question? Any question? Chong?
I think no question.
You are all right, right? Okay. Chia Wing Long, Chia Wing Fong.
So far, no for me, sir.
Okay, good. All right. Let me check back. Joshua, anak lelaki guna sekekaran. Are you there? I ask one more time. Joshua, anak lelaki guna sekaran. Are you there? Vina, are you there?
I'm here, sir.
Okay, good. Brian, are you there? Brian? Brian, are you there? Okay, let me try the chat room. Okay, Brian, I saw you reply in the chat room. Brian, what happened to your mic? All right, we continue. Okay, so the same thing, same question, same set of question. For example, a formula will be given, and then we can do a lot of things from the velocity vector. Question 7 asks you to plot the velocity field, and question 12 asks you to plot the streamline. Okay, we look at stick line. Stick line, it consists of all the particles that previously passed through a common point. Now, what does it mean? if you play basketball, so if you throw a basketball and you use a camera to capture at each, like for example, T0, T1, T2, T3, every second you snap one time, you will see the image overlapping on your photo. You will see, for example, on the slide here, you will see there's a basketball in a gray color. So all this gray color, and then you connect it with the line, it will become a stick line. This is what it means by this sentence. A stick line consists of all particles in the flow that have previously passed through a common point. Means all these are the common point. Okay, you see this one, right? So these are the simulation, wind tunnel simulation, all the smoke. You see the smoke, especially the third line on the screen here. If you follow this one, this is a stick line. You see this one? All right, the third category of line, we call it path line. Path line is a line traced out of given particle as its flow from one point to another. Okay, now stick line is I circle. Again, I repeat. So stick line is I highlight the gray color. All these are stick line. All these are stick line. Path line is the dot, red dot there. This is path line. Okay. Stick line is here. Is what I highlighted with the yellow. So in this case, I just give you two examples. So the one that gray color, the gray color basketball is the stick line. Okay. Right. The last example for today lecture, question 15. So on question 15, given a two-dimensional velocity field given by so and so, we have u equal to 1 plus y. Let me change the font of this. Okay, more readable. Determine the equation of the streamline. You see, it asks you to establish the streamline. Pass through the origin. On the graph, plot this streamline. Again, no, there's one more question on this. Okay, never mind, we'll solve for question 15 first. Right, now again, the step is recall what is streamline equation. We have a dy dx equal to v divided by u. So this one is the standard one, right? So recall the streamline equation. We are given u and v. Recall this now. So dy dx equal to v divided by u. So in exam, if you write out the general equation, you are given marks for that one. Then you substitute the value given in the question. For example, u, in this case, u equal to 1 plus y. You substitute in the u location. V, substitute there, you get dy dx equal to 1 divided by 1 plus y. So this is very direct. So to establish streamline, we always start with the dy dx and then we do integration. Now to start integration, we rearrange the equation. You put y one side, x one side, dy one side, dx one side, and then put in the integration symbol. Like this. Right? You pull y one side, x one side. Okay. Then you put in the integration sign. Okay. Now in this case, we are not given the boundary condition yet because we are in the chapter 1. So in later on, you will see more complex case where you are given the bounding condition, where your integration sign here, you will see point A, point B, or from 0 to 2 or 0 to 5 or something. In this case, we are still using the general equation with the constant value. So if you integrate left-hand side, integrate 1 plus y, you'll get y plus y squared divided by 2 plus constant value 1 on the left-hand side. And then, of course, the x, the right-hand side, you'll get x plus constant value number 2. Again, if you don't understand how to integrate, go and read up your calculus integration chapter. So you rearrange, you combine the constant value together, you'll get x equal to y squared divided by 2 plus y. And let me see. Yeah, plus constant value. Means you move the constant, you group the constant value C1, C2 together, become a common constant value. You get this one. Then you want to find the constant value. What is the constant value here? You put in the boundary condition. This is a common approach. We will put x is equal to 0, y equal to 0, because it asks you to, it also give you the hints that this streamline pass through origin. So origin, we know that everything is 0, x equal to 0, y 0, z 0. So in this case, we have a 2D condition. So our x equal to 0, y equal to 0. You put inside this equation, x0, y0, you get your constant value equal to 0. So in this case, we don't have constant value. So you rewrite the equation, x equal to y squared divided by 2 plus y. So this is our streamline equation. Okay, streamline equation. So again, if you don't know how to plot a graph, again, you can use online material that I showed you just now. You rearrange this equation, right? For in this case. So how do you type in this equation? So on the screen here, I already show you one example. You type in x equal to y plus, of course, half you can write in the digital form, 0.5, or you can use a divide equation also. So I'll show you using my screen here. I will open a new one. So our equation is x equal to y squared divided by 2 plus y. So I just put in my equation here. X equal y plus, if you don't know how to do, just very straightforward. Straightforward. Y squared divided by 2. So how do you do it? You can either use 0.5, or you can go to the keypad there, y squared divide here, divided by 2. Also same, and then remember, always need to close your equation. We also close your equation. Then from this graph, you will see this is the streamline for the equation given, like this. Okay. So you get this shape. Okay, you get this shape from the online platform calculator. All right. Now the next thing is we don't want to know the direction of the streamline. It's either from the top or from the bottom. We want to add in the arrow here. We start with the dy dx equation again. And our velocity is more than 1. In this case, our velocity is 1 given in the question. V equal to 1 means it's more than positive. So your V component here, your V component is positive, means it's go up. So your streamline on the this portion, you know that is following this direction. Okay, following this direction is pointing up. And then you know that this streamline is have a direction. So bottom one, you just add in the arrow here. Just follow the line to complete the presentation. Okay. We have done with the shape of the streamline with the direction. So in your exam, you'll be given some marks for the curve shape and also the direction. All right, so each one of it will carry some marks. So in your exam, if you do not include the arrow, mean you don't get the full marks for the streamline. Again, what is the float speed at the origin? What is the float speed at the origin? So here. All right. Now at intersection location, the coordinate is 0, 0. You know the x equals 0, y 0. Then in the equation here, back to equation, u equal to 1 plus y equal to 0. So your u component is 1. In this case, you are not given any unit yet. All right. So if you really want to put in unit, then the unit will be unit divided by time, right? Unit square, unit divided by second. In this case, there's no unit given. So you just put in u equal to 1, v equal to 1. Then recall the magnitude of the resultant, magnitude of the vector given by square root of x component, y component, z component, u square plus v square plus w square. So in this case, we only have two-dimensional flow. So we only have u component, v component. Substitute this value inside this general equation. All right. So you know that at origin, this is at origin. At origin. At origin, your u equal to 1, v equal to 1. Only at origin. At other location is not 1. In this case, at origin, because the question asks you to find the float speed at origin. And of course, maybe you come to your final exam, you're asked to determine a certain speed, the speed magnitude at a certain location. Okay. Substitute in, you know that 1 square root 1, you always get 1. 1 plus 1, you get square root of 2. Is it correct? Let me see. It should be 1.414. Your magnitude should be 1.14. It's not right. It's not 1 here. Velocity is 1.14. Unit over second. All right. Now we have one more question, which is question 16. We will continue this question in our next lecture. You can try it out as your homework today. It won't be marked, but just as a homework. If you look at question 16 on the tutorial question, the question asks you, given you water flowing through oscillating slit out, given the velocity vector so and so. Don't be scared by the equation. Just stick to the principle and the procedure that I teach you just now. Put the equation in x, y, z component, and then see what question want you to do. If the question asks you to draw a streamline, then you start with the dy dx and then integrate. get the u, v, w, and then dy dx, and then integrate. And then you're given some parameter there. Okay. If you compare the screen and your tutorial question, the hard copy, the U0, the 0 actually is a sub node, sub 0. It's not a big 0. All right, so especially there's a last line in the question there, just above the find word. The velocity of the oscillating sprinkler head, given an equation, U equal to U0. Right, the 0 is a sub, not the big 0. Then you need to find streamline, path line, and also the shape of the stick line. So that one we will cover in the next lecture. Okay, I will revisit the concept for chapter 1. So for today, actually, we already cover your chapter 1 content. Okay, we already cover chapter 1 content. Because chapter 2 is a very big chapter, the time given to cover for 1 week is not enough. Okay, so we will enter into chapter 2 a bit earlier so that we can cover most of it. Okay, let me check the attendance again before we end our session here. Have you turned on your webcam? So I can see most of you. This is Sue, Bila. I see Bila. Who else? Only see 2. Turn on. Okay. Let me. Okay, I stop the recording for today.